So good morning to all and welcome you all for the 28th lecture on basic circuit theory. So where we are, anyone? Successfully we completed unit 3 and I started the first half of unit 4, and unit 4, right? To summarize the last class, we started with the unit 4. Actually this is unit 5, okay, as per your syllabus. Okay, resonance and two interesting keywords. One is resonance and coupled circuits. I told you earlier, okay, syllabus overview for resonance. Syllabus overview for resonance. You are having two type of resonance. One is series and another one is parallel. So first you want to know the concept of series resonance. Then you want to know the variation of impedance V equal to IR. Just remember the formula R, I and V with frequency. And here three interesting concepts: bandwidth, quality factor and selectivity. So here also first parallel resonance. So what is parallel resonance? What is the condition for parallel resonance? Okay. Then the same two topics: variation of impedance, voltage, and current with respect to frequency. And third one is bandwidth, quality factor, and selectivity. Actually, why is it so called ECE? Electronic and Communication Engineering, right? So second one actually two parts. One is electronics, full and full circuits. The next one is communication. That uh, even though you may belong to mechanical department, but you might have heard FM. You are using telephone, okay, and you are watching TV. Everything is coming under communication, right? That is communication. But how to communicate? With the help of circuits we are communicating. So first, around 4 semester in ECE we will study about circuits, and for semester onwards we will move to communication. With the help of circuits, if you are good in circuits, then communication concept will be easy for you people. The same way, first 2 or 3 units we studied about circuits. Now with the help of circuit, okay, we are going to study some small, okay, concepts, okay, related to communication. So this unit full and full communication point of view, okay. But circuits or otherwise application of circuits, can I take in that way? Okay. So first you want to know series resonance. Let me put the heading series resonance. What is the resonance? Any idea? Now take this guy, resistance, that resistance R, the current I, the voltage V. My question: what is the phase relation between voltage and current here? What is the phase relation between voltage? V equal to I times R, right? What is the phase relation? What is the phase relation? Both are in phase or out of phase? Both are in phase or out of phase? Anyone? Please answer. Current and voltage are in phase or otherwise out of phase. When phase will come into picture, when you will be playing with the complex number, at the time only you will play with the angle, right, theta. அப்பதான் phase உள்ள வரும். இங்க all are real number, so both are in phase. Both are in phase. My first circuit element. Coming to inductor, that right? Inductor. What is the conclusion I have given? Inductor current lags voltage by 90 degree. Take third element, capacitor, voltage lags current by 90 degree. This already you know, right? Now my question, what do you mean by series circuit? So now connect all these things in series. Take one inductor, sorry, first resistance R, L, C. What is the impedance offered by this resistance? R. Reactance offered by inductor J times XL. Okay. Reactance offered by the capacitor actually 1 by J C omega or XC omega, right? XC. Okay. If you will include J, then you will get actually minus J, right? Because you know XC which equals, how can you write this? 1 divided by J C omega. The magnitude it is 1 divided by, can I write? Okay. Magnitude. So it becomes minus J XC. Okay. So the reactance offered by the capacitor, it can be written minus JXC. Now I'm going to apply some voltage, take some Vs, source voltage. Now take this current I. Now, what is the phase relation between this applied voltage Vs and this current? Both are in phase or out of phase? Any idea? If you are having only resistors, if you are having only resistor in phase, if you are having only inductor out of phase, where current lags voltage by 90 degree. Only capacitor out of phase, where current, voltage lags current by 90 degree. But here the concept is different. If we will connect, okay. See, this is, as I told you earlier, voltage source, that is your grandfather or grandmother resistance, number, inductance capacitors, appa amma. Okay. See, in my circuit, I want to have inductor capacitor, but what is the resonance here? So I told you earlier, if you will make resonance with your family, or if your father and mother both are resonance to each other, then you will get maximum happiness, right? In the same way, in the circuit here, this is my circuit. Okay, because of this inductance and capacitance, okay, my applied voltage and current because of the voltage both are out of, but under some condition both must be in phase. That condition is called resonance. Okay, so what is resonance? Okay, when total applied voltage, total applied voltage and current are in phase, even though inductor and capacitor are present. That is the beauty. Even though inductor and capacitor are present, but this applied voltage Vs, okay, is in phase with I. In under what condition this must be satisfied? For that, you want to find, okay, what is your I? I equal to V by R, right? I equal to V by R. Here what is R? R plus JXL, all are connected in series. So simply add everything, JXC. So I equal to V divided by R plus J times XL minus XC. Okay. Now listen this carefully. So actually this is my Vs, right? Vs. Okay. So now, when this applied voltage Vs and the current both are in phase, under what condition? Both are in phase means, okay, so here you are having some phase, here you are having some phase, okay. I want to have the same phase for this current. So in order to make the same phase for the current, what about this denominator? This denominator, it won't have any imaginary part. It may have real part alone it may have. Suppose if you are having, okay, this is Vs by R. Now my I equal to Vs by R. Okay. Now what is the phase for this Vs? Same phase for current. Okay. And you will get the maximum current under this condition. So now what is the condition to satisfy this? Therefore, when XL equal to XC, I want to make this one as 0, right? So now take J times XL minus XC equals to 0. Therefore, XL equal to XC. That is the condition for resonance. It's very, very important. Okay, condition for actually series resonance, right? Okay, so this is the way. So what is resonance? Don't write XL equal to XC. This is the condition for resonance. So resonance means when applied voltage, okay, and current are in phase, even though inductor and capacitor are present in a circuit, every family அப்பா அம்மா இருந்தாலும் family smooth run ஆகுது இல்லையா, same way ஒரு சர்க்கியூட்ல opposite kind, right? Both inductor and capacitor opposite இருந்தாலும் under some condition we want to get, okay, the applied voltage and current are in phase. That condition is called resonance. So resonance, this is the definition for resonance, okay. And from this is the condition for resonance. It's very important, please maintain it. Okay, so condition for resonance, XL equal to XC. At resonance, what is my maximum current? Therefore I max, right? At resonance, if XL equal to XC, the current is given by Vs, right? Applied voltage divided by resistance. Okay, XL and XC won't come into picture because both will be cancelled by each other. Okay, so now, so this is the first formula, XL equal to XC. And now at resonance, the current is given by I equal to V by R as per Ohm's law. Okay, so now the third one to derive resonance frequency. Resonance frequency FR. Okay, what is the condition for resonance? XL equal to XC. Yeah, what is the formula for XL? Anyone? Actually, the condition is nothing but magnitude of XL equal to magnitude of XC. Okay, reactance offered by inductor, take the magnitude, equals reactance offered by the capacitor. Anyone please let me know what is the reactance offered by the capacitor and inductor. What is XL? L omega. XC
1 by C
1
omega.
by, I'm looking for, now take this omega squared equal to actually 1 by L, right?
Yes.
Therefore, what is my omega? 1 divided by square root of LC. Okay, this is in terms of, radian per second. But omega equal to 2 pi f. Okay, so now if XL equal to XC, at that time the frequency is called resonance frequency. So what is the definition for resonance frequency? At resonance, the frequency is called resonance frequency. When XL equal to XC, that frequency is called resonance frequency, right? So omega R squared or omega R equal to 1 divided by square root of LC in terms of radian per second. But in terms of hertz, so omega R equal to 2 pi FR equal to 1 divided by square root of LC. Therefore, my resonance frequency, very, very important formula, 1 divided by 2 pi square root of LC. Okay, this is my resonance frequency formula. This is in terms of radian per second. This is in terms of hertz. Both are very, very important. Please make a note. Okay. This one only yesterday I have told. Okay. You are changing the knob, right? Actually, inside a FM. Okay, inside FM hardware, you can find one LC circuit. You can find one series RLC circuit. Okay. Actually, the resonance frequency formula 1 divided by 2 by square root of LC, where L is fixed. By changing, you are changing the knob, right? Actually, you are varying the capacitance. By varying the capacitance, you are fixing this frequency. You are fixing this frequency. It may be 93.5 for Surya FM, 98.3 for Mirchi, okay, and 106 for Allo FM. That story you know, right? So this is the way. So please, hereafter, please keep it in your mind. When you are changing the knob, okay, please think about me, not think about me. Please keep it in your mind. When you are changing the knob, you are changing the capacitance, right? Please. So how frequency changes when you are changing the capacitance with the help of this formula. Okay, this formula is very simple that you know. You want to know both the formulas in terms of radian per second. What is the formula? 1 divided by square root of LC. In terms of hertz, F equal to 1 divided by square root of LC. Okay, so this is about the third formula. Okay, so first one XL equal to XC. When at resonance, what is the current? Current is given by Vs by R and resonant frequency F. Okay, so now variation of it's quite interesting. So we completed series resonance. That's it. Okay, these are all the three concepts you want to know. Now the next topic, variation of impedance with respect to frequency, right? With respect to frequency. Quite interesting concept. I hope so you will enjoy. Okay. So now listen me carefully. X-axis, okay, and Y-axis. This is my frequency. X-axis, this is my reactance, right? It may be XL or XC, right? You know the formula for XL. Take the magnitude alone. XL equal to L omega, okay? Where omega equal to 2 pi F, okay? So here frequency and the reactance both are, okay? Frequency and the reactance both are direct proportional to each, direct proportional to each other or inversely proportional to each other. Frequency and impedance both are okay, direct proportional to each other. Okay, if we will sketch this, if we will increase frequency, what will happen to reactance? And what about this? You know, y equal to mx plus c, right? Where c is the constant. If we will remove c, we will get y equal to mx. Here also xl equal to 2 pi f, same way. So if we will sketch this, actually you will get a straight line, right? You will get a straight line which passes through origin. Okay. Now this is my, XL magnitude L omega. Okay. Now, first one, coming to XC, take the magnitude 1 by C omega, where omega equal to 2 pi f. So XC 1 by 2 pi fc. Now both are directly proportional to each other or inversely proportional to each other. Inversely proportional to each other. Now if we will plot, okay, if we will vary frequency and if we will plot XC, what equation will you get? It looks like, say, rectangular hyperbola having here. Rectangular hyperbola. So if we will draw this, okay, if we will draw this, you will get a curve, okay, like this. And this is my XC equals 1 by C omega, magnitude of XC. Okay. So now listen me carefully. XL, L omega, 2 pi f, both are directly proportional to each other. So you will get a straight line. If you will sketch XC, you will get rectangular hyperbola. because both are inversely proportional to each other. If f equal to 0, you will get, see, for xc, f equal to 0, what will happen to xc? Xc infinite, you will get maximum value, right? Here you are getting maximum, right? Infinite. If when frequency increases, f equal to infinite, xc becomes 0. So actually infinite to 0 it is traveling. Okay, so you will get an exponentially decreasing curve, nothing but a rectangular parabola like this. Okay, it's very important. Okay, any doubt till now? Now, what is the condition for resonance when XL equal to XC, right? See, this is my XL and this is my XC. Both are connecting at this point, right? Here you will get this one XL equal to XC. At this point, the frequency is called resonant frequency. Okay, so curve எப்படி இருக்கும்? What about this range? This is F is less than resonant frequency, this range. Here F is greater than resonant frequency. Okay, at resonant frequency, at resonant frequency, what is the resistance? The resistance given by R. Now this range, take this range. Okay, here who is dominating? Take this range here to here, here to here. Okay, here F is less than FR. XL dominates or XC dominates? Anyone?
XC, sir.
XC, very good. So in this range, XC is very, very greater than XL, right? Let me write it here. XC is very, very greater than XL. That's what. When frequency is less than resonant frequency, the circuit will act as, capacitive. At resonant frequency, circuit will act as resistive. Now, when F is greater than FR, this range, when F is greater than FR, now who is dominating? XL or XC? Is this guy? XL, this may XC. So XL is very, very greater than XC. So inductive in nature. Okay. See, sometime வீட்டில் வந்துட்டு அம்மா வந்துட்டு டாமினேட் பண்ணா அப்பா கொஞ்சம் அட்ஜஸ்ட் பண்ணிட்டு போறாருல. சம்டைம் அப்பா பண்ணா அம்மா அட்ஜஸ்ட் பண்ணிக்கிறாங்கல்ல. பட் ஆல்வேஸ் நம்ம இப்போ என்ன நியூட்ரலாக இருக்கணும் இல்லையா? ஸோ அட் ரெசோனன்ஸ், கேன் யூ ரிலேட் திஸ்? At resonance, resistive in nature. Even though R and C are present, but at resonance, at FR, right? Circuit behaves like a resistor. Frequency less than resonance frequency, it acts as capacitive, right? So capacitive in nature. Capacitor is dominated. F is greater than FR, inductive in nature. Okay, so see, can you roughly draw like this? So variation of this my F and this is my impedance, right? First, at resonant frequency I am getting minimum impedance R. So till resonance, okay, gain decreases, sorry, impedance decreases, then impedance increases. Okay, so at resonance you will get minimum impedance that is given by R. Okay, when F is less than FR, impedance decreases. F is greater than FR, impedance increases, right? From this curve. Decreases, then increases. At resonance, you are getting minimum impedance. So this is the variation of impedance with respect to frequency. I repeat the diagram, okay? Frequency in terms of hertz. Here, impedance, Z, okay? So at the resonant frequency, we will get the minimum impedance that is nothing but R, right? So till R actually here, okay. So here actually in this range, XC is very, very greater than XL. Here XL is very, very greater than XC. At this point, it is R. Okay. So this diagram you want to remember. This concept is very, very important. Okay. So now take this. This is the variation of impedance with respect to frequency. Any doubt? So this curve, you know, right? This curve, how it came, that and all, you know, from this, okay, by sketching these two. From this diagram, okay, you know how to sketch this. Now my question, variation of current with respect to frequency. What is the relationship between current and impedance from Ohm's law that, you know, V equal to I times R. From this, you know, I equal to V by R. Okay, so I and impedance R both are inversely proportional to each other. Okay, so now if we will sketch, sorry, I mean here again frequency in terms of hertz, but this time this is I current, okay, in terms of ampere or milliampere. If we will plot this curve, the curve எப்படி இருக்கும்? Any guess? From this relation, I equal to V by R, both are inversely proportional to each other. So will you get a curve like this? Okay, or a curve like this. Soon, one
First
or
one,
two.
sir.
First one,
One.
yeah, very good. So at resonance, see this curve, see this impedance curve. At resonance, you are getting minimum resistance. So at resonance, you will get maximum current, right? So at resonance, you will get maximum current. Okay. Since both are inversely proportional to each other, current and resistance, so obviously இங்க எனக்கு இப்படி இருந்துச்சுன்னா இங்க என்ன ஆட்டோமேட்டிக்கா இந்த மாதிரி curve வரும். So you won't get this. Okay. So this is the variation of which one? Current with respect to frequency. It's very simple. This is one way, or another way. Now take this RLC. This is your R L C. Here I am applying some voltage. Yeah. Now the current, okay, this is my I. This is R, this is J L omega, where omega equal to 2 pi F. This is minus J, okay, or what is this? 1 divided by J 2 pi Fc. Okay, what is this F here? Here F equal to infinite, starting, ending F equal to, sorry, here starting F equal to 0, ending F equal to infinite. If F equal to 0, what will happen? What will happen to inductor? If F equal to 0, what will happen to I? In order to find that, if F equal to 0, what will happen to inductor? XL equal to 0. XL 0 no open or short circuit, open circuit. Open circuit means what is the current? Current I equal to 0. That's what here it is 0. At F equal to 0, it is 0. Now, if F equal to infinite, what will happen? F equal to infinite, at that time, capacitor will act as open circuit. How? X equal to 1 divided by 2 pi, take the magnitude 2 pi Fc, where F equal to infinite, so 1 by infinite 0. 0 means again open circuit. So open circuit means again current equals 0. So when frequency F equal to 0, inductor will act as open circuit. L open circuit, therefore current 0. At high frequency F equal to infinite, capacitor will act as open circuit. So at that time that time also current is zero. That's what at low and higher frequency, current is zero. So when you will get maximum current, that concept at resonant frequency, since your impedance is low, so at that time you will get maximum current. So this is the variation of I with respect to frequency. Okay. So now this I max formula, that Vs applied voltage divided by only R, because XL equals XC. So from this formula, that from this relation, okay, here XL equal to XC, so you will get Vs by R. Okay, so now based on this concept, we will solve some four problems. Then you will understand. Then you will get the clarity. Take example one. Okay,
So can you show the last two equations, madam?
which
Okay,
equation?
okay. And the last
Don't worry.
inductor open circuit.
Just to understand it, you want to know this curve. Okay, variation of current and variation of impedance. Then finally variation of voltage, that we will discuss after solving some problem. Okay,
Okay.
so take the first problem. Determine the value of capacitive reactance. Determine, just to think this, I will give you enough time. I don't want to. It's just by seeing the diagram itself, you can give the answer. Just one more. Determine the value of capacitive reactance and impedance and impedance at resonance. Read the question carefully. Determine the value of capacitive reactance and impedance at resonance. Take the circuit. Series RLC, right? I'm applying some voltage. Vs. So this is some 50 ohm. This is some J25 ohm. This is minus JXC. Yeah. You want to find two things. First one is XC at resonance. Okay. And second one is jet impedance at resonance. Anyone? At resonance, what's the condition for resonance? Just think and let me know the answer from the given things. Anyone got the answer?
Sir, XC 25 ohms, sir.
Yeah, very good, ma. The first one, at resonance, okay, when XL equal to XC, resonance occurs, right? When XL equal to XC. Therefore, I'm looking for XC. So XC equal to XL. From the given, okay, what is this? J times XL, actually, this is right. This is J times XL. So therefore, XL equal to 25 ohm. That is the value for XC. Okay. So this is J25. So this is obviously minus J25 ohm. So both will be cancelled. Okay. Then resonance will occur. What is the condition? Second one, impedance at resonance. At resonance, what is your impedance? At resonance,
50
what is
ohms.
your
50
impedance?
ohms.
50. I don't want to explain much. Okay. I want to move to the next problem. Example 2. Find the resonance frequency. Find, okay, resonance frequency. Take this, take the another circuit. Take this 10 ohm, 0.5 millihenry and 10 microfarad. I'm giving some resonance. Find resonance frequency FR. So what is the formula? Simple formula, right? FR equal to, what is the formula? Resonance frequency formula 1 divided by 2 by square root of LC. Hertz. Very important. So 1 divided by 2 by, where L equal to 0.5 milli. So 0.5 into 10 power minus 3 into C, 10 micro. 10 into 10 power minus. What is the value, anyone? Simple for problems. 1 or 2 mark. Okay. But you can understand the concept behind resonance by solving this problem. Resonance frequency 1 divided by 2 pi. Take your calculator. What's the answer? Anyone? None. Please verify, are you getting 2.25 kilohertz or not? Take the third problem. Find I max. Okay, find the maximum current. Take this problem. Find the maximum current. When maximum current will occur?
Resonance.
At resonance, so maximum current will occur. Okay, and what is the current from this diagram? Okay, the
2.
current is given by I max equal to V is by R. Okay, so this time don't look for this JL and J, XC and all. Just at resonance you will get maximum current. So at resonance I equal to V by R, but only you will get this R. XL and XC and all will be cancelled each other. So V is 10. Take the magnitude alone. Okay, because I am having only resistance real part. No need to consider the angle. Okay, no need to consider the angle. Take the magnitude. Okay, it is 10. The R is 5. It is 2. So maximum current 2. Can you find a minimum impedance for this circuit? Z min. Minimum impedance. Anyone? When minimum impedance will occur? At resonance. At resonance, minimum is given by
5 ohms.
Thank you. Okay, and one more problem. Take example number 4. Then we will move to variation of voltage with respect to frequency. Take example number 4. So this is somehow 6 more question. Determine the impedance. Okay, at resonance frequency. You want to calculate 3 things. First one, determine determine the impedance, okay, at resonance frequency. Determine the impedance at resonance frequency. Second one, 10 hertz, okay, below resonance frequency. Third one, 10 hertz above resonance frequency. Okay. Take the circuit. Take the first circuit. L and C value I want to give, right? I'm looking for the what value I can give. Let me take my material. Give me 1 minute. Forgot the L and C values. Yeah. It is 10 ohm. This is 0.1 Henry. This is 10 micro. Yeah. Now proceed. Determine the impedance. We want to calculate the impedance at resonance frequency. Then 10 kilohertz below resonance frequency, 10 kilohertz above resonance frequency. And just for your information, you know the variation of frequency and variation of impedance with respect to frequency, how it would be, at resonance you will get minimum curve இப்படி இருக்கும். So now let me take, this is my resonance frequency. So this range, okay, this is my frequency which is less than resonance frequency. Here who is dominating that, XC is very very greater than XL, okay, and here F is greater than FR. This XL is very very greater than XC. To realize this concept, okay, I have chosen this problem. At resonance you will get, minimum impedance. So what is the solution for A? That, impedance, okay, at resonance is nothing but R, that is given by 10 ohm. Okay, that is the minimum impedance. Now subdivision B, 10 hertz below FR, impedance at 10 hertz below FR. So for that you want to calculate FR, right? What is resonance frequency FR? 1 divided by 2 pi square root of LC. 1 divided by 2 pi. Guys, are you there? 1 divided by 2 pi square root of L, where L is 0.1 and C is 10 micro. What is this answer? Anyone? Can you help me? What is this resonance frequency? 1 divided by 2 pi square root of LC hertz. Okay, since here it is given in terms of hertz, 10 hertz below, 10 hertz above.
160 hertz.
160.
60.
Okay, approximately you are telling it is 160 hertz. Okay. Therefore, what is this? Impedance 10 hertz below means so 160 minus 10, 150 hertz, right? So impedance at 150 hertz. Okay. So what is the formula for impedance that you know? Formula for impedance, since all are connected in series, right? All are connected in series. So in general, it is R plus J times XL minus J times XC. So it is R plus J times XL minus XC. Take the magnitude, so square root of R squared plus XL minus XCD whole square, right? Magnitude square root of A square plus B square, where A equal to R, B equal to XL minus X. So you want to calculate this XL and the XC at this 150 hertz, right? Now listen. What is my X? Okay, L at 150 hertz. XL equal to L omega, where omega equal to 2 pi f. So 2 pi fl. 2 pi is constant. Here frequency is 150. Inductance 0.1 Henry. What is this value, anyone? So XL. Similarly, can you find XC? Okay, XC 1 by C omega, or omega equal to 2 pi fc. So 1 divided by 2 pi is constant. F equal to 150 into C 10 micro. Let me know both the values. And here, as per concept, when frequency is less than resonant frequency, when frequency is less than resonant frequency, Xc should be very, very greater than XL, or at least Xc is greater than XL. Please verify this, whether this property is satisfied or not. By with the help of numerical number, you can understand this, right? That's what I have chosen this problem. Now, what is the value for XL? Anyone? Calculator, yeah. Take the calculator and let me know the value.
XL 94.24, sir.
94.24 unit is ohm, right? Yeah. Xc 1 divided by 2 pi square root, I mean 2 by 150 times 10 micro. இருக்கிற எவ்வளவு தாங்கிறீங்க? Don't take more time. You are good in calculator. 1 divided by 2 pi times 1 divided by 2 pi 150 into 10. So what is this value? Anyone? என்னாச்சு கால்குலேட் ஒர்க் பண்ண தெரியலையா? Don't take anyone, please help me. என்னாச்சுடா? If you will calculate, you will get 106.11. So Xc is greater, 106 is greater than 94, right? Yeah, it is satisfied. Therefore, what is my impedance at 150 hertz? That is the formula is R squared. Okay, plus this time this is Xc minus XL. Okay, so equals square root of what is my R, that R equal to 10, right? R equal to 10, yeah, 10 squared 100 plus what is my Xc? Xc is 106.1 minus XL 94.24 the whole square. Okay, if you will calculate this, okay, you will get approximately 16.32 ohm. Please verify. This is the way to calculate impedance, okay, at 10 hertz below resonant frequency. Impedance at 10 hertz below. Now can you calculate impedance at 10 hertz above? 10 hertz above means so impedance at what is my error? So 160, so it should be 170. So here XL should be greater than XC. Okay. So the formula is R square this time XL minus XC the whole square. And please verify, are you getting XL is greater than XC or not? So XL equal to L omega or L equal to 0.1 omega 2 pi. This time F is 170 hertz. What is this value, anyone?
106.8.
0.1, 106.8
6.8
ohm, right? Yeah. Then
ohms.
what is XC? Is 1 by C omega, where C is 10 micro, and omega 2 pi. F is this time 170. What about this value?
93.62 ohms.
Very good. 93.69 ohm. So here see, the condition is satisfied, right? XL is greater than XC, right? What is my XL? It is 106.8 is greater than 93.6. Okay. Whereas here, okay, can you feel the difference? Therefore, what is my jet at 170 hertz equals square root of 10 square 100 plus this time XL 106.8 minus 93.6 the whole square. What is this value, anyone?
16.48, sir.
16.482. This is the impedance at 170 hertz. Okay. So impedance at 160 hertz, it is 16.32. Can you draw this? You will get the same curve. This is my impedance at resonance. Okay. At resonance, actually what I got 10, right? So minimum. Can I fix 10 here? Okay. When frequency is less than resonant frequency, so this range 10 hertz below, 10 hertz above, 10 hertz below it is 16.32, roughly in your okay. So you will get a curve like this. Roughly over 16 point, which again is 16.3. So here also it is again 16.4, right? So it is over 16.4 epsilon. Okay, so at resonance frequency, impedance is minimum 10 ohm, whereas here, it is XC is greater, so capacitive. Here XL is greater, so inductive. Okay, so this concept is very, very important. Okay, now my final topic for today's class. Actually, I want to teach this, but time will left. So I will give the diagram alone and the explanation and the problem. Next class we will see. So variation of voltage. Okay, with respect to frequency. Here one more interesting concept is that. Okay, see the beauty. Try to understand my question clearly. Okay, with this I will wind up. Next 5 minutes. Assume I am applying some 10 volt, right? 10 at an angle of 0. 10 volt. What is the voltage drop across resistance at resonance? I write the question. My question is, what is the voltage drop? What is the voltage drop across or at resonance. Anyone? Check, this is my J times XL, this is minus J times XC. At resonance, what will happen? XL equal to XC, so both will be cancelled. Appa enga, what is the voltage drop across R? That's what VR equals. How much? If I apply 10 volt, you will get all the 10 volt must appear across resistance, because the reactance of inductor and capacitor both are cancelled, right? So resonance circuit la yaar mattum dhaan irupanga? Resistor. You know the behavior of circuit at resonance, it is resistive. So you will get only resistor. So 10 volt கொடுத்தீங்கன்னா, what is the voltage drop across resistor? 10 volt. Okay, but actually ideally it is zero. Ideally these two zero. 0 volt ன்னு சொல்றோம். But some voltage அங்க இருக்கும். Some reactance may be there. Okay, some lower reactance. So some 0.5 volt or maybe some 0.2 volt. ஸோ இந்த 10 வோல்ட் இங்கே அப்பியர் ஆகாது, ஒரு 9 வோல்ட் இல்லை ஒரு 9.5 வோல்ட் அந்த மாதிரி இருக்கும். ஓகே, ஸோ நவ் ஐ எம் கோயிங் டு ஸ்கெச். ஓகே, தி வேரியேஷன் ஆஃப் இப்போ சீரிஸ் சர்க்கியூட்டை கரண்ட் இஸ் சேம், அதனால ஒரு கர்வ் இருந்துச்சு. பட் வேற voltage drop across, okay, resistor, this is VR, voltage drop across inductor, VXL, or take simply VL, voltage drop across capacitor, VC. So this time you want to sketch three curve, because since all are connected in series, so in series voltage will be divided, so you will get three different voltages. Okay, let me take, this is my applied voltage. I am applying some voltage Vs இங்க இருக்குன்னு வச்சுக்கலாம். Applied voltage Vs. Okay, now when frequency increases, curve எப்படி இருக்கும்? What is the curve for resistance? So but what is the maximum voltage drop across R? That is applied voltage, but you won't get same 10 volt, so you will get some 8 volt or 9 volt. So voltage drop across at resonance frequency FR. Okay, so this is my voltage drop across resistance. At resonance frequency you will get maximum voltage. Okay, so till resonance frequency voltage increases, after resonance frequency voltage decreases. Okay, now what is the voltage drop across inductor? What is the voltage drop across capacitor? It's very interesting. You know, in this range, who is dominating, and in this range, who is dominating? Here you know XC dominates, here you know XL dominates, right? So maximum voltage drop across capacitors occurs before resonance frequency. Okay, write the sentence, the statement. Note, maximum voltage drop across capacitor occurs before resonance frequency. We know the reason why. Similarly, maximum voltage drop across inductor occurs after resonance frequency. Okay, but what is the maximum voltage drop? My question, I applied 10 volt, will you get more than 10 volt across inductor or capacitor? ஒரு பழமொழி சொல்லணும் இல்லையா, Kirchhoff's voltage என்ன சொல்லுது? Applied voltage equal to sum of dropped voltages. Yeah, that is satisfied here. But my question, நான் சொல்லியிருப்பேன் சட்டியில் இருக்கிறதா அகப்பைக்கு வரும் அப்படின்னு. ஒரு 10 மாவுக்கு தோசை இருந்துச்சு, 10 தோசைக்கு மாவு இருந்துச்சுன்னா எத்தனை தோசை சுட முடியும் உன்னால? 10 தோசை தான் சுட முடியும். நீ ஒரு 10 வோல்ட் அப்ளை பண்ண அப்படின்னா மேக்ஸிமம் 10 வோல்ட் தான் இருக்க முடியும் சர்க்கியூட்ல. பட் ஹியர் த பியூட்டி, the voltage drop across inductor, it may be more than 10 volt. Across capacitor, more than 10 volt. But if we will add the voltage drop across, okay, this one, if we will add this voltage across VR plus VL plus VC, you will get this VS. Yeah, this is your, KVL. Kirchhoff's voltage law will be satisfied here. No problem in it. But my question, for 10 volt kurtena, will you get more than 10 volt? Yeah, here that beauty may happen. That's what this circuit is called, voltage magnification circuit. Okay, mathematically I will prove it later. But now if you will sketch, okay, when maximum voltage drop occurs, okay, across capacitor before resonance frequency, if you will sketch that, you will get a curve like this. Okay, till here, then after that, okay, now this is, this frequency which is less than FR. Okay, and take this frequency is some F's of, okay, capacitor, right? FC. What is FC? The maximum frequency, or the frequency at which maximum voltage drop occurs across capacitor. Similarly, across inductor, let me choose another color, black, red, black. Okay, so let this time choose this one. Okay, take this is my FL, frequency at which maximum voltage drop occurs across inductor. ஸோ என்ன ஆகும், இது வரைக்கும் இன்க்ரீஸ் ஆகிட்டே போயிட்டு இதுக்கப்புறம் டிக்ரீஸ் ஆகிடும். ஓகே, ஸோ திஸ் இஸ் த த்ரீ கர்வ்ஸ். ஓகே, 10 வோல்ட்டோட அதிகமாக இருக்கும் if you will measure across inductor alone or across capacitor alone. But if you will add everything, you will get 10 volt. Because here this is J10 JXL, it is minus JXL. Both will be cancelled. That I will prove it later. But this is the frequency, I mean variation of voltage, okay, with respect to frequency. It's very interesting concept. Okay, till now what we thought, சட்டியில் இருக்கதான் அகப்பைக்கு வரும். ஆனால் இங்கே சட்டியில் கூட அதிகமாக வரும். இன்னும் பழமொழி சொல்லுவாங்கல்ல, அப்பா 8 அடி பாஞ்சா மகன் எத்தனை அடி பாயணும், 16 அடி பாயணும், ரைட்? நம்ம அப்படித்தான் யோசிப்போம் எப்பவுமே. இப்போ நான் வந்துட்டு ஒரு டீச்சராக இருக்கேன்னா என் பையன் என்னவா இருக்கணும், என்னை விட பெட்டராக வரணும் இல்லையா? I am applying the voltage, but I am expecting more voltage, like your real life. Here also it is possible. That concept I want to stress here. Okay, I didn't complete this variation of voltage with respect to frequency, floating, right? Yeah, you may get a lot of doubts. Tomorrow session I will give you the overview. Then I will start the same topic. Okay, variation of voltage with respect to frequency. Then we will solve one or two problems. What is FC? What is FL? Okay, then you will get the clear idea. But this curve is very, very important. So you know what is the curve for current, curve for impedance, and curve for voltage, right? These three is very important. And you know what you mean by resonance. And you got some stuffs, okay, regarding resonance. Okay, so thank you. Thanks for your attention. Those who are having doubts, okay, you may stay. Others, you may leave. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.